Hello everyone and welcome. In today's video, what we want to accomplish is to modify such a chip adapter to work with the larger hard drives, the 3.5-inch ones. So this one usually works just fine with the smaller laptop hard drives, but the problem is that in order to use it with the larger 3.5-inch hard drives, you have to power the hard drives with an external power supply, usually a 12 volts one. So in order to modify this, we will have to disassemble this small adapter, check out the pinout for this connector here. This is for data and this is for power. And then we will simply solder some wires to this connector to provide the 12 volts power that is missing. So let's get to it. First of all, I'll disassemble these ones since they are built quite cheap. They will come apart quite easily. So simply put something in this small gap here and pry it open. So as you can see, it will come apart quite easily. Okay, so we have the board. Now what we're interested in is the actual pinout of this adapter. So as you can see, it has quite a lot of pins on this side here, and the ones we're interested in are actually the last three ones from here, which will be plus 12 volts. So these ones here should be the plus, and the next three ones here will be the minus. So we'll have to solder some wires there, and then we are actually ready to use this adapter with the larger hard drives. But another thing that I want to do is to actually have the power provided by a USB Type-C power supply or phone charger. So I will use such a device that can provide between 9 and 20 volts. So this one is already configured to use 12 volts, which is exactly what we need. So let's see how it works, or if it works. Let's start with that. So I'll power my multimeter here, and then I will power this adapter here. Okay. And now let's check the output. So as you can see, we have 12 volts here, which is just perfect for what we need. Okay, so let's see if we have the polarity on here, so that's great. We'll know how to wire this up. Okay, so let's get to it now. So first what we'll need are a couple of wires. I've got some here. Not really sure if they are way too thick for this. And this should be fine. I will cut from this old SATA cable. And then let's make a little bit of room here. I want to make a test fit first. So let's see if everything will go in here nicely. So this will be the bottom part, or is it? No, it cannot be, since actually it can. So the LEDs are here, this part will come here, so this should go in like this. Okay, and let's take our adapter and see where we can put it, so we can make it work. I think I've just lost it, but we will take another one for this test right now. So what I'm trying to do is to put it somewhere here. Let's try it again. So something like, maybe like this, or let's put it something like this maybe, so we can cut the device, the case, and see how that goes. Okay, so it should be something like this, and I will have to put the wires on the opposite side of this connector here. So I will solder on this side, so maybe the other way around will be easier. So I can use shorter wires. So let's take it out and put it the other way around. Okay, something like this. So we can fit everything inside. I'll have to reroute this wire somehow, but I think we can make this work. So something like this. Okay, it looks doable. Okay then, let's mark the points where we'll have to cut, and let's do just that. Okay, so I'll have to cut here and here. I hope I can see them. Yes, I can. Okay. And let's cut them using this. Okay. And on the other side as well. Okay, and now let's try to get this part out. Not the best cut I have ever done, but this should do it. Okay, so let's take a look. It looks something like this, and let's try the USB-C connector. And I found the other device here. Okay. So it should go in something like this. I need to cut a little bit more. Okay, let's do just that. Yeah, that should do it. Okay. And there it is. Yeah. That should work just fine. So I will have to glue this in, but not before I will solder the wires. So let's get to that now. Okay, let's take a board holder and let's start soldering. I will try to lock this here for now, so we can solder in more easily. I hope I don't break the USB wires there. Okay, and I will need some power for my soldering iron. And some solder, of course. I think the wires should be quite short, but first let's thin these pads here, these pins. This is way too hot. Okay, this should be good. I should use some flux here, but well, that will work just fine. And of course the other one there. There is no problem if we bridge these pins, since they are connected in parallel anyway, so yeah. Okay, we have that. Now let's put some wires I will first start with a positive one. I will tin it in a moment, but maybe these ones are a little bit too thick for this, but we will see. And of course, let's take one for the negative side of the same length. We should use some better wires for this. Yeah. Okay, so let's get to it. I think, yeah, we're still okay with the connections here, so that is good. And same here, okay. The connections are fine. I will get some wires and we'll solder some thinner ones next. Okay, so we got some thinner wires. As I've said, for such a short distance, the resistance is quite low and we should get away with using these ones. So yeah, let's strip them. These are from some kind of old USB cable, so we should be good. Actually, I think I'll solder first, as I did the last time, the negative one, since it will be easier to solder the other one anyway afterwards. So let's tin it and then we can solder. Yeah, that is good. The same for this one. Okay, so now we have this wire. Let's solder it in place. I think I'll cut it a little bit shorter. Yeah, something like this, or even a little bit shorter, something like this. Okay, so let's solder this first, but let's clean the tip of this soldering iron first. Okay, this one solder in nicely. Let's do the same for the other one as well. And then we can measure the length and cut them accordingly this time. Okay, so it seems that they are soldered perfectly. Okay, now let's do a test fit first to see if we can put everything in here. Okay, and now we know the length of these wires and we can cut them a little bit longer anyway, since these ones will allow us to push them under the PCB. Okay, so this one I can cut it right here, and this one I can cut it right there. Okay, so let's get to it. This time I really have to be careful because I really need all those little wires inside. So nothing gets hot from the resistance, and the same goes for this one as well. Okay, we have the wires. Let's tin them and see how it goes. Okay, let's cut them a little bit shorter. Yeah, that should do it. The same on the other side as well. Okay, so we have this. Now let's see how we will solder this so we can assemble everything in the end. So we should be able to do this. Okay. Yeah, that should do it. Let's do the other side as well. Okay, everything looks fine. Now the last thing I want to do is take a piece of wire and put it over that board, since I want everything to be just fine and not make a short circuit anywhere. Okay, that should do it. And now let's see if everything fits back together. This is always the hardest part with such projects. Okay, it should go in something like this. Let's find the other side right here, and let's put everything back together. And it looks something like this in the end. It seems that I need to cut just a little bit from this side here, but I will do that afterwards. For now, let's see if everything blows up in. So let's get to it. Nothing happened, exactly what I was expecting. So yeah, I will try to get a hard drive and see if that works. Be right back. Okay, so sadly the only hard drive 3.5 inch that I have is an IDE one, so I cannot show it right now if this thing actually works, but what we can do is see if this thing will blow to pieces if you try with a normal hard drive. So if these ones get 12 volts, they really don't care, but if we've made any kind of mistake, it should blow up. So let's give it a try. So right now, this is a hard drive. Let's test it out. Let's see if we get some kind of. Okay, seems to be working fine. And now let's put 12 volts right here and see how that goes. Okay, so it drew about, let me check once again. So it seems it does not care really that much. Yeah, 0.2 watts. It doesn't really care about the 12 volts rail, but in theory this should work. So I'll try to post a video when I get a 3.5 inch hard drive with the results, and I'll keep you posted. So that's it for now. The real benefit of using such a solution like this one is that maybe you don't have a barrel jack on hand at any point, so you can actually use any phone adapter that supports 12 volts output, or even a power bank. So if I would have a Type-C cable at hand, I could use a power bank to give 12 volts to this adapter and use that to power a hard drive. So thank you for watching. Goodbye.